Hello, good day. Welcome back to another math video. Today, pag-uusapan natin about complex numbers. So before we start, let us try to go back first to the concept of the discriminant of the quadratic equation. So we know that if the discriminant is equal to 0, the roots of our quadratic equation are real and equal. If above 0 or greater than 0, the roots will be real and unequal. If less than 0, the roots will be imaginary and unequal. For example, we have the equation 9x squared minus 3x plus 2 is equal to 0. So, to make use of the discriminant, we need to identify first our a, b, and c. So in this quadratic equation, our a is 9, our b is negative 3, and our c is a positive 2. So let's try to plug these values to our discriminant. So we have again d, or the discriminant, is equal to b squared, or negative 3 squared, minus 4. Our a is 9, our c is 2. So, and then we will have, this is 9, negative 3 squared is 9, negative 4 times 9, 36 times 2 will become negative 72. And then 9 minus 72 will give us a negative 63. Now, based from this discriminant, negative 63 is actually less than 0. So we are to expect that the roots of our quadratic equation will be imaginary and unequal. So we are to expect again that the roots will be imaginary and unequal. So from this alone, what are imaginary numbers? But before that, let's try to um, solve this quadratic equation first for us to see whether the roots are really imaginary and unequal. So to do that, let's try to make use of our quadratic um, formula. So we have x is equal to negative b plus minus the square root of b squared minus 4ac over 2a, and then again we're going to plug or substitute our values to our formula. We will have the negative of the negative 3 plus minus the square root of negative 3 squared minus 4 times 9 times 2 all over 2 times 9, and this will give us 3 plus minus 9 minus the square root of 9 minus 72 over 18, or 3 plus minus the square root of negative 63 over 18. Now, if you notice here, we actually have here negative square root. Alright, so again, we have here a negative square root. So again, if we are going to use our calculator, if we are going to find the value of the square root of negative 63, it will give us an error. So again, this is an example of imaginary numbers. So from this, what are imaginary numbers? So the imaginary number, denoted by our friend I here, has the following property. Number 1, I is equal to the square root of negative 1. So therefore, if we are going to get the square root of negative 1, that is just equal to I. Right? So again, this is the first one. And if we're going to do the reverse, so we have I squared, it will give us negative 1. This is the second one. So again, take note, the square root of the negative 1 is I, represented or denoted by I. That means imaginary. And then I squared is equal to negative 1. And then, for any positive real number n, the square root of the negative n is equal to I times the square root of n. So later, we will have an example for us to better understand this concept. Exercise 1. So for example, we have here the square root of negative 6. So again, we all know that negative 6 is a factor of negative 1 times 6. And then earlier, we know that the square root again of negative 1 is actually I. So therefore, we can actually separate these two. We will have negative 1, the square root of negative 1 times the square root of negative 6. And again, we know that the square root of negative 1 is I. And then 6 is not a perfect square, so we leave it as is. So our answer will be plus minus I times the square root of 6, or since this is multiplication, we can do this one. So we have plus minus I times the square root of 6. Or you can also write it this way, plus minus square root of 6I. Alright? But then again, both are actually correct. Just a matter of preference in writing. Next example, we have the square root of negative 20. So again, negative 20 can be rewritten as negative 1 times 20. And then, what we will do is separate the two. We have the square root of negative 1 times the square root of 20. And then, we all know again that the square root of the negative 1 is just I. So we have plus minus I, and 20 is not a perfect square. So we leave it as is. So our answer will be plus minus I times the square root of 20, or plus minus square root of 20I. So again, both answers are correct. It's just a matter of preference in writing. More examples. So we have the square root of negative 5. So this is equal to negative 1 times 5, and then negative 1, the square root of negative 1 times the square root of 5, and that will give us plus minus I times the square root of 5. This will be our answer. Alright, last example. So we have here the square root of negative 25. So negative 25 can be rewritten as negative 1 times 25. And then we will write negative, the square root of negative 1 times the square root of 25. And again, the square root of negative 1 is I. And then negative 25 actually is a perfect square, so we have plus minus 5. So in this example, we will have plus minus 5I. So again, this will be our final answer. So that is how we simplify numbers in terms of I. Next, we are going to talk about complex numbers. Now, a complex number is any number that can be written as a plus bi, where I is the imaginary unit and a and b are real numbers. So this is the form of our, actually this is the standard form of our complex number. So again, a complex number is a combination of a real number and imaginary number. So we have a plus bi. This is our real part, and then this will be our imaginary part. Alright? So again, this is our real part, and then this will be our imaginary part. And again, a plus bi is actually the standard form when we are dealing with complex numbers. So later in our examples, when we talk about standard form of the complex numbers, we are referring to a plus bi. So to better understand this concept, let's try to have this exercise. Alright, so I have here complex numbers. So the first column contains the complex numbers, and then the second column will be the standard form, and then we are going to identify the real part and the imaginary part of our complex numbers. Alright, for a while, lobat yung laptop. And then, So let's start with the first example, 7i minus 2. Again, when we talk about standard form, we are referring to a plus bi. So we are just going to rewrite everything or rearrange the complex numbers, and then we will have negative 2 plus 7i. Our real part will be negative 2, and then the imaginary part will be 7. Right? If you want to solve along, you can actually pause this video. Second example, we have 4 minus 3i. Now, again, standard form is a plus bi. So the standard form of 4 minus 3i is just 4 plus negative 3i. So from here, the real part will be 4. The imaginary part will be a negative 3. Next example, 9i. So again, standard form is a plus bi. So actually, we don't have a real part here. So we will write 0 plus 9i. And then the real part will be, of course, 0. The imaginary part will be 9. And then, last one, we have negative 2. Standard form, we have negative 2 plus 0i. And then the real part will be negative 2. And then the imaginary part will be, of course, 0. So again, that is how to write complex numbers in standard form and identifying the real and imaginary part as well. So again, if you do have questions, kindly let me know. Alright, now let's try to proceed with operations involving complex numbers. So let's have first addition and subtraction. So addition and subtraction of complex numbers. So when we add or subtract um, complex numbers, we are going to treat them like binomials, how we add and subtract binomials. For example, add the following complex numbers. Example 1, 8 plus 2i plus the quantity of 9 plus 7i. Again, when we add binomials, we actually group the like and the like terms. So in this example, actually, by the way, this is our real part, the one in yellow, and then the imaginary part will be the one in ano ba yan? That's blue. So again, when we add binomials, we actually add like terms. So in this example, what are like terms? So we have the real part and the imaginary part. So we will write 8 plus 9 plus 7i plus 2i. And then what is 8 plus 9? That will just give us 17. And then 7i plus 2i is just 9i. So therefore, this is our final answer. Alright, next. We have the quantity of negative 6 plus 4i plus the quantity of 8 plus 7i. So again, combine like terms. So we will have negative 6 plus 8 plus 7i plus 4i. And then we will have 2 plus 11i. So again, this will be our final answer. Next, the quantity of 12 minus 9i plus the quantity of 8 plus 3i. So again, combine like terms, we will have 12 plus 8 plus 3i minus 9i. And then this will give us 8 plus 12 is 20. 3i minus 9i is just negative 6i, or simply this will become 20 minus 6i. So this will be our answer. Next, we have the quantity of 1 minus 9i plus the quantity of negative 3 plus 7i. Again, combine like terms, we will have negative 3 and 1. So we will get 1 minus 3, and then 7i minus 9i. This will give us negative 1. 1 minus 3 is negative 2. And then we have 7i minus 9i is negative 2i. Simplified, this will give us 2, a negative 2 minus 2i. So that will be our final answer. Next, let's have subtraction. So again, the same concept, subtract like terms. We have here the quantity of 8 plus 2i minus the quantity of 9 plus 7i. So again, identify our real and imaginary part and then combine like terms. So we will have 8 minus 9. By the way, let's try to do it this way. First, we are going to distribute the negative sign. First, we have negative times positive is negative. Negative times positive again is a negative. So that is why we have here 8 plus 2i minus 9 minus 7i. And then combine like terms. So we will have 8 minus 9. Again, 8 minus 9 plus 2i minus 7i. So 8 minus 9 is just negative 1. And then 2i minus 7i is just negative 5i. So this will be our final answer. Alright. Next. Again, subtract the following complex numbers. The quantity of negative 6 plus 4i minus the quantity of 8 plus 7i. So again, identify our real and imaginary parts. And then we are going to distribute our negative sign. So what will happen again is we have 8. A negative times positive 8 is negative 8. And then negative times a positive 7i will give us a negative 7i. And then combine like terms, we will get negative 6 minus 8 plus 4i minus 7i. So negative 6 minus 8 is just negative 14. And then 4i minus 7i is negative 3i. So this will be our final answer. Alright. Next, we have the quantity of 12 minus 9i minus the quantity of 8 plus 3i. So again, distribute our negative sign, negative 8, and then this will become negative 3i. And then combine like terms, we have 12 minus 8 minus 9i minus 3i. 12 minus 8 is 4, negative 9, a negative 9i minus negative 9i minus 3i will give us negative 12i. So again, this will be our final answer. Alright, last for subtraction. Quantity of 1 minus 9i minus the quantity of negative 3 plus 7i. So again, distribute our negative. This will become positive. And then this will become negative. Then combine like terms. So we have 1 plus 3 minus 9i minus 7. 1 plus 3 is 4. Negative 9i minus 7i is negative 16i. So again, this will be our final answer. So that is how to subtract complex numbers. Next, we'll have multiplication and division of complex numbers. Now, when we multiply and divide complex numbers, again, we are going to treat them the way we treat binomials. So for example, we have here the quantity of 4 plus 5i times the quantity of 2 minus 3i. Again, we're going to make use the FOIL method, or we're going to distribute the, to get the product of these complex numbers. So we are going to multiply again 4 plus 4 times 2. That will give us 8. 4 times negative 3i will give you a negative 12i. And then we have 5i times 2 will give you 10i. And then 5i times negative 3i will give you negative 15i squared. Now, next is we are going to combine like terms. So negative 12i plus 10i is just negative 2i. And remember that I is equal to the square root of the negative 1. So if we have I squared, this is just equal to negative 1. Now, here we have I squared, right? So this is just equal to negative 15 times the negative 1. And that will give us positive 15. That is why we have here 8 minus 2i plus 15. Then simplify further, we can actually combine 8 and 15. That will give us 23. So our final answer will be 23. Let me just create a small box here. Alright, so our final answer will be 23 minus 2i. Next, multiply the quantity of negative 6 plus I times the quantity of 3 plus 2i. The same method, we are going to distribute. So we'll have negative 6 times 3 will give us negative 18. Negative 6 times 2i is negative 12i. And then I times 3 will give us 3i. And then I times 2i will give us 2i squared. Then again, the same thing, simplify and combine like terms. So negative 12i plus 3i is just negative 9i. And the same here, I squared is negative 1. So negative 1 times 2 is negative 2. Then combine like terms, negative 20 minus 20, negative 18 minus 2 will give us negative 20 minus 9i. This will be our final answer. Alright, we'll have two more examples. Example number 3. So we have the quantity of 7 plus I times 6, the quantity of 6 plus 5i. So again, distribute, simplify, and then combine like terms. So 7 times 6 is 42. 7 times 5i is 35i. And then I times 6 is 6i. And then I times 5i is 5i squared. Combine like terms and simplify. So we have 35i plus 6i will give us 41i. Then again, I squared is negative 1 times 5 is negative 5. So we will have 42 minus 5 is 37 plus 41i. That will be our final answer. Next, the quantity of 9 minus I times the quantity of 9 plus I. So again, distribute. We have 9 times 9 is 81. 9 times I is 9i. I times negative I times 9 is negative 9i. Negative I times I is negative I squared. Simplify. We have 81. This will be cancelled out. 9i minus 9i is 0. So we have 91. Again, I squared is negative 1 times negative. That will give us positive 1. So our answer will be 81 plus 1 is 82. Alright. So again, that is for multiplication of complex numbers. Now, how to divide complex numbers. So again, when we divide complex numbers, it is the same with dividing binomials or rational expressions. So for example, we have here 10 plus I divided by 10 minus I. Now remember, when we divide binomials, we actually look for the conjugate. The conjugate of the denominator, and then we are going to multiply our entire expression by that conjugate. So what are conjugates? For example, we have quantity of 1 minus x. The conjugate of this one is just 1 plus x. Alright? The same with x minus 5. The conjugate will be x plus 5. So basically, we are just going to change the sign. So in this example, our denominator is 10 minus I. So what is the conjugate of 10 minus I? Right? So again, the conjugate will be what? 10 plus I. Very good. So we are going to multiply our expression by 1 using the conjugate. So we will have 10 plus I over 10 minus I times the conjugate, which is 10 plus I over 10 plus I. Remember, if we are going to simplify this one, this part of our um, solution, this is actually 1. So basically, we are not changing the entire thing. No, we're not changing a thing to this particular expression because again, remember, any number variable multiplied by 1 is the number itself or the variable itself. Now, the same with what we did earlier, we are going to um, simplify. All right. So we are going to multiply. Um, Let me do it here first. 10 quantity of 10 plus I times the quantity of 10 plus I. So using again our FOIL method, this is actually what? 100. And then we have plus 10I plus 10I plus I squared. Alright? Simplify 100. 10I plus 10I is 20. And then, what is I squared again? That is just negative 1. So, 10 plus I times 10 plus I is equal to this numerator, or 100 plus 20I minus 1. Now, what about the denominator? Now, 10 minus I times 10 plus I is actually the same with what we did earlier. The shortcut for this one is just what? Um, Multiply this two. So we have 10. So we have 100 plus negative I times I is actually what? Negative I squared. But remember, I squared is negative 1. So this is 1 times negative 1 or 1. So our answer will be 1 plus 100. So that is where we get 10 plus 100 plus 10 here. So I hope that is clear. Now we are going to simplify. So we have um, 100 minus 1 is 99, and then 20i. 100 plus 1 is 101. Express this one in standard form, we will have 99 over 100 plus 20 over 99 over 101 plus 20 over 101i. And this will be our final answer. Next example, we have 3 minus I over 4 plus I. So again, what is the conjugate of our 4 plus 1 is just 4 minus 1. So multiply everything by 4 minus I over 4 minus I. I keep on committing a mistake when saying I. I always read it as 1. Sorry for that one. Again, that is I. Now, the same thing earlier, we are going to multiply. What is 3I times 4 minus I equal to? So, FOIL method, we have 12, and then minus 3I minus 4I plus I squared. Simplify, we will get what? 12 minus 7I. This is what? Minus 1. Alright, and then we will have 11 minus 7I. So our numerator part is equal to 11 minus 7I. Now, here, the same pattern earlier, this is just equal to what? 16 plus 1 or 17. So again, our denominator is 17. Our numerator is 11 minus 7. So again, we have here 11 minus 7I over 17. And then simplify, we will have 11 minus 17, 11 over 17 minus 7 over 17I. That is again our final answer. Alright, final answer. Next, 5 plus 5I plus, 5 plus 5I over 4 plus I. So again, the conjugate of 4 plus I is just 4 minus I. So let's try to compute first our numerator. We have 5 plus 5I times 4 minus I. Again, FOIL method. 5 times 4 is 20. 5 times negative I is negative 5I. 5I times 4 is positive 20I. And then 5I times negative I is negative 5I squared. Simplify, we will have 20 plus, this is positive 15I. What is I again? I squared? It's negative 1. So negative 1 times 5 is positive 5. So this will give us what? 25 plus 15I. That will be our numerator. Then again, the same with what we did earlier, our denominator will be 16 plus 1 or simply 17. So again, numerator is 25 plus 15I over 17. So again, our numerator will be 25 plus 15I over 17. Convert or transform into standard form, we will get 25 over 17 plus 15 over 17I. And this will be our final answer. Right, that will be the end of this discussion. Thank you so much. As always, if you have questions, kindly let me know.